So I hope you're feeling experimental today because we're going over the process of paper chromatography, one of the key labs you need to know for GCSE Chemistry. So let's dive in. We've got a lot to get through. So paper chromatography, it's a process where mixtures of soluble substances are separated. So a solvent, which is a mobile phase, is run through a mixture on paper. And on the paper, we have the stationary phase, okay? The substances will then move up the paper at different rates. The most soluble substance will move the furthest up the paper, okay? So what do we do to begin with? We dip the chromatography paper into the solvent. So we dip the bottom of the chromatography paper into the solvent, okay? Then we have a little bit of movement, okay? So things start to get moving. The solvent travels up the chromatography paper. And as the solvent moves, it picks up the substance being tested and carries them up the chromatography paper. Now, we all care about distance. The component that travels furthest is the most soluble. So that means it dissolves really easily in the solvent. And they are also minimally attracted to the chromatography paper, okay? So those are the key variables that we're going to look at when we're analyzing paper chromatography. So let's do a quick review. In paper chromatography, which phase is the chromatography paper and the mobile phase is solvent? So it's the stationary phase is the chromatography paper and the mobile phase is the solvent, okay? So just to review that one more time, the stationary phase is the chromatography paper and the mobile phase is the solvent. Okay, now we've got a few more definitions to get over, so let's go over some more. Chromatogram, that is what we produce from chromatography, and we use this to identify compounds in mixtures by calculating RF values. So what are RF values? Basically, that's the distance traveled by the substance divided by the distance traveled by the solvent, okay? We can work this out for both reference substances and tested substances. So let's go over what a solvent is. So a solvent is something that is that's the mobile phase of chromatography, right? And our RF values depend on the solvent. We can learn more about the identity of the components by testing any reference and the unknown mixture in a range of solvents, okay? And what are those reference substances? Basically, it's a pure sample that runs alongside the unknown mixture to see if it's a component in the mixture. They provide valuable evidence, but not proof, okay? That's really important. So do you remember what chromatography produces? It makes a chromatogram, and that's what we analyze to identify the identity of compounds in the mixture. And the two things we need to calculate the RF value, that's the distance traveled by the substance and the distance traveled by the solvent. Okay, let's go over the different phases in chromatography. There are two phases, which is also covered in the previous episode looking at purity and formulations. So make sure you check that out to consolidate your knowledge. And first of all, we have the mobile phase, which is either a liquid or a gas. And then we have the stationary phase, which is a solid or viscous fluid, okay? And substances that are strongly attracted to the mobile phase and minimally attached to the stationary phase, those are the ones that move the furthest. Okay, do we remember how to describe a reference substance? Basically, it's something that's used in chromatography. It can provide an indication of substance presence, and it's a pure sample, okay? So let's go over the practical. So how does this all come together, okay? So the practical investigation, we have paper chromatography, and it separates out mixtures. And this is our cute little process. So first of all, we use a pencil to draw a horizontal line near the bottom of the chromatography paper. Don't go using a pen up in here because that pen has got to separate, like it's got loads of different components in it. It's going to run across the paper. So we want to be using a cute little pencil, okay? And so definitely not a pen. Remember that. That will lose you exam marks. Now, that pencil line, that's our start line, and we put samples of known food colorings, A to D, alongside an unknown substance, X, okay? We then place the paper in a beaker containing a small volume of solvent, okay? We then wait for that solvent to travel up near the top of the paper. So the solvent's having a cute little journey to the top of the paper, okay? And by comparing spots produced by X and those produced by A to D, it should be possible to identify the unknown substance, okay? So X is our unknown, and then A, B, C, and D, those are our cute little references. And then we can compare how far X travels, how far A, B, C, and D travels, and use that to identify it, okay? So, do you remember what we put on the start line? We put samples of known substances alongside an unknown substance, okay? And if the RF values of a reference and a spot match in all solvents, it's very likely that the mixture contains the reference compound, okay? Now let's talk about a little bit of analysis. So let's take an example, and let's say that the solvent traveled 10 centimeters, okay? And let's say reference A traveled 3 centimeters. So how do we calculate the RF value? Well, nice and simple, we do 3 divided by 10. So it's the distance that the reference traveled divided by the distance that the solvent traveled, okay? So 3 divided by 10 would be 0.3. Now, let's do a different reference. Let's say reference B traveled 8 centimeters. How would we calculate the RF value? Well, just like before, it's the distance that the reference traveled divided by the distance that the solvent traveled. So 8 divided by 10 is 0.8. Okay? Now, our tested substance, let's say that traveled 3 centimeters and 6 centimeters. So there are 2 spots. Spot 1 would have an RF of 3 divided by 10, 0.3. And spot 2, 6 divided by 10, 0.6. Boom. So spot 1 of the tested substance has the same RF value as reference A. That means that the tested substance contains reference A. Okay, that's how we interpret the results. The RF value for reference B doesn't match either spot, so that means that the tested substance doesn't contain reference B, because reference B traveled all the way to 8 centimeters. Okay, so in paper chromatography, the components that travel furthest are minimally attracted to the chromatography paper and highly soluble in the solvent, okay? Now, do we remember how to calculate that RF value? It's the distance traveled by the substance divided by the distance traveled by the solvent, okay? So, good thing to remember, most of the time that's going to be less than 1 because the solvent's what's going to be traveling furthest. So that can be handy when getting your answer together. Now, what apparatus do we need for paper chromatography? We need that chromatography paper, we need a beaker, and we need some solvent, okay? Now, do we remember what the stationary phase is? That's chromatography paper. And the mobile phase, that's our cute little solvent, okay? And if we're drawing a start line, are we going to use a nice little like biro, or we're going to get like a 2HB pencil? Honey, we're getting a pencil. We don't want to be using no pen because that's going to run, that solvent is going to separate out all the different components in the ink. So we're using a pencil, okay? That's what we want. And where does the solvent move in paper chromatography? It moves on up. Do you know what else is moving on up? Your chemistry knowledge. Thank you for listening to this episode. Good luck with all your revision, and I will catch you in the next episode. Okay,